Today, we're going to design and implement this serverless AI architecture using AWS. We will build an end-to-end system where a client uploads an image and the backend returns a machine learning insights using AWS Rekognition. Let's start setting up the infrastructure. Before we implement the compute layer, which is Lambda, we need to configure the IAM role. Let's go to IAM role, create IAM role, choose Lambda as a service. This Lambda function requires two permissions, one to invoke the ML inference and next one to access the image which we will upload to S3. So search for S3. So read only permission is sufficient. Next one, we need to have the ML inference permission. We are going to use AWS Rekognition for this image inference. So this policy also needs to be added. Let's say name a role. Okay, these are the two policies required. One which will help us to access the S3 image, and this one will help us to invoke the recognition ML model. Create role. This ensures Lambda can securely access both input data and the AI service required. The role got created successfully. Now let's focus on Lambda function. This function acts as an orchestration layer between API gateway and recognition service. Okay, let's go to Lambda, create Lambda function. We'll name it as Serverless ML. Go for runtime, choose Python as a runtime. So we created the role already, so we're going to use that role, which is Serverless ML role. Create function. Alright, so function got created now. Now let's add an API gateway to this Lambda function. Add triggers, go for API gateway, create new API gateway, REST API. We'll keep it open now. That's it. So this one will add an API gateway to the Lambda function. Okay. Now let's modify the code for the Lambda function. Okay. So I already have a code here in a Colab, in a VS Code. Okay. Let me explain this Lambda code. First, pass the incoming request from the API gateway, and then it will extract the S3 bucket and the object key. Using this bucket and key details, it will invoke the recognition model, and then the response from the recognition model will be structured as a JSON format, which we will be receiving from the client side, and we are responding back. Okay, so let's take this code, paste it here, deploy. Okay, code got deployed now. Alright, next let's focus on the client side. I already created a client script which you can reuse. Okay, so this is the client script I have. So as per the Lambda code is expecting the payload with the S3 detail from the API gateway. So we need to first update our endpoint for the API gateway in the client script. So API gateway, copy this, replace. Okay, and the client perform two operations. One, it will upload a file to S3, and with that object reference, it will trigger a API gateway. Okay, as expected by Lambda is expecting this S3 bucket path as well as the path for the key. Okay, so let's execute and see. And before that, this is the image we going to upload to S3, and our ML is going to inference this image and give us the insights. Let's execute this. This pattern is completely used in a backend system where file storage and processing are decoupled. Okay, so we got the inference result here. So it was able to identify most of the objects in the image. It was able to identify a person, house, lawn, everything. So it was working as expected. We successfully built a serverless AI pipeline on AWS using S3, API Gateway, Lambda, and Rekognition service. This is a production-ready pattern. We can extend this architecture further by adding asynchronous processing using SQS. We can store the results using DynamoDB, or we can do an advanced search using OpenSearch. Thanks for watching and subscribe for more videos.